Okay, let's make some announcement first. Okay, guys, can we start? We did pretty well on Wednesday, didn't we? Okay? Okay, people at the back, I'm only going to warn you once, okay? Only once. You know what I'm going to do if I warn you more than once. Okay, guys, let's have some announcement quickly. For this week, you're going to do Lab 0 Part 2. Just to mention very quickly, you must go to your registered lab session to have your lab graded. In case you have not registered yet, you must go to the Tuesday 5 p.m. session there, okay, to get yourself graded. And for next week, the week of January 21st, we have your quiz number 1. And for the week after, we have your lab test number 1. But for both of them, I'll give you a preparation guide and some examples for you to start. Okay, I'll hopefully make them available by Wednesday's class, so don't panic, okay, just to let you know they are coming. Okay? Guys, this level of noise is still not acceptable. All right. Let's talk about the subjects. So last time we talked about literals, we talked about operations, operator, and operands. So now we talk about something that's slightly more complicated, which is called data types. Okay, we're going to learn about some very simple data types as you have seen in the tutorial videos, but later on in the course, we're going to learn about more complicated ones as we learn about objects. But let's again focus on the simple ones. So what's really data types? So here is how you can understand it. I'll just give you some example, which you have seen already in the class. Okay. So now let's see some example over here. Okay. Let's look at the simple ones. You have integer, you have double, you have char, which stands for character, which I'll talk about in just a moment. And also we got string, and also we have Boolean. So these are the data types, at least for now, we can now focus on. After the reading week, we're going to learn about something called reference data type, which is about object-oriented programming. So we'll get there later on. Now, for the data types over here, so what's really the use of data types? Basically, whenever you declare a data type, that constrains what value you can store in the corresponding variable. For example, over here, let's see the very first one. If I declare variable I over here as of type integer, you can think about I is more like a box over here, and then what can we store inside the box? You can only store integers, but nothing else. For example, you can store 23 over here, that is okay. But if you try to store a string, let's say 23 over here in quote, it would not be acceptable. Okay? Similarly, let's say we have another data type over here, let's say character, char over here. And then we say we declare a variable C of type char over here. So what does that really mean? It's a similar idea. So if you look at this line over here, so that means whatever you can assign to this particular variable must be of type character. So now, that's how you can look at that. So now if you think about this, a box over here called C, the only thing you can store inside the C is a single quote literal. For example, it can be character C over here, but if you try to store 23, a number, it is not compatible, okay? Or if you try to store, for example, hello over here, that's also not compatible, okay? So now we're actually going to see more and more cases like this. Here's the bottom line. Whenever you declare your variable to be a particular type, you must stick to it and then store only compatible values into it. We'll see more and more type errors like that, okay? And then we learned about Boolean type over here for Lab 0 Part 2 videos. So we know that whenever you talk about Boolean data type, you only allow two possible values, true and false, right? So that means you can only store either true or false inside this particular variable b. Okay? That's kind of the idea about data type. As soon as you declare the type of the variable, you can only store that value inside. Yes? Sorry? You cannot hear me properly? Is it because it's too loud over there? The microphone. Okay. If that's about the microphone, give me just 1 minute. I'm going to change the battery, all right? Okay, is it better? All right. Okay, let's start again. Sorry about the interruption. All right, so now let's go back to the data types. For this week, we're just going to focus on several simple data types, okay? All right. Okay, good. All right, let's go to the slide here. So now, integer type. I would say as far as this course is concerned, most likely you would just use a type called int over here. So when should you use the other types? I would say it's more about like a very low level issues which we don't have to worry about for the programming concern. Okay, I would say for this course here, you just have to know, you just have to use int if you want to store a number without a fractional part. Okay, for others, if you want to use a long, it's simply because it has more capacity for you to store a big number. You don't really have this kind of concern until you get to 2030, the later course. But for this course, it will be safe for you to use integer. It's going to use 32 bits to store the integer. Okay, and if you want to store a number with a fractional part, so you're going to use most likely double. Okay, just use double. Okay, and then if you want to store a character, which means a single quote, only a single character over there, use char. Okay, you can see char, C-H-A-R over here. We haven't really used the char character so far in the lab, but I'll give you some assignments this week. Okay, so you can practice. Okay, we also got a string type over here, and notice one thing. You can see all the types byte, short, int, long, float, and double, and char. So far, all the spellings are all lower cases, right? On the other hand, the string type over here is capitalized. Okay? For now, you don't have to worry about why such difference. There's a reason for that, which we'll cover when we talk about objects later. Okay? But for now, just make sure when you declare string type, make sure you capitalize S over here. Okay? So now, here's exactly the point you want to keep in mind. As soon as you declare a variable of a particular type, you have to stick to it. Okay? You cannot store any value that's not compatible. Okay? That's something we'll see more examples later. Okay, that's about data type. Now let's talk about assignments over here, which we also briefly touched upon in the tutorial video last week. So now for assignments, let me just introduce to you the terminology over here. Okay? You can also read the slides. It's the same stuff. Let's consider these 4 lines of code over here. Let's introduce the terminology, okay? So now basically, you can see that, let me just use, okay, the orange one, int, and int. So these are, as I just introduced, they are called data type. Okay, in this case, we just use int. And then on the other hand, let's use over here. So when you say I over here, J over here, and K over here, they are right besides the data type. So these are called variable declaration. Okay? So these are variable, especially the name of the variable declaration. Okay? Now, what about the equal sign over here? The equal sign over here, let me highlight it. So the equal sign here, equal sign here, equal sign here, equal sign here. So these are called the assignments, which means you're kind of changing the value that is stored in the variable. So we're going to trace the program, just 4 lines of code, and see what happened. So whenever you see the single equal sign, that means you want to change the value to some variable, just some value. Okay, and let's see over here. And we got 24 here, 32 here, and also we have another variable name. and we have another variable name. So they appear on the right-hand side of the assignments. Okay? Okay, over here, you see that on the right-hand side of the equal sign, we actually got something over here. Okay? So let me introduce them. Either you can say they are the right-hand side of the assignments. That's one way to call them, which is very straightforward. Or you can say they are the source of the assignments. The source of the assignments. Okay, either way is fine. Okay, let's talk about the left-hand side, and then we'll talk about what they really mean. The left-hand side, where you can see I, J, I, K over here. Okay, so they are called the targets of the assignments. The targets of the assignments. And alternatively, you can also say they are the left-hand side of the assignments. Okay, either way. So you got left-hand side, you got right-hand side. Okay, so now let's see exactly what they really mean one by one. Okay, when you look at line number 1 over here, line number 1, what you're doing is you're declaring a variable whose name is I. You can think about conceptually, you have a box called I. And since we say the data type is actually integer, you can only store integer inside this box, which is called I. And then we say we want to change the value for the box over here. Whenever you see equal sign, that means to change its value. And initially, for the very first time, we're going to change it to 24. Okay, that's what line number 1 will do. Okay, make sure you're comfortable with such tracing. And line number 2 over here, okay, we are declaring basically another variable over here called J. So what we have is, we have J over here. Okay, we have J over here, and then we are saying that we're going to assign a value from the right-hand side, which is the source. In this case, that'll be 32. Okay? Now, one more thing to say. Okay? If you look at line number 3 over here, let me just highlight it over here. Line number 3 is kind of interesting. If you look at line number 3, I is assigned to J, right? You can see that over here, if you compare these two lines, if you compare line number 3 and line number 1, we're basically having the same left-hand side of the assignment I and I. However, for this particular later occurrence of I, we don't have to declare int again. Okay, that's intentional. Okay, every time, as soon as you declare the variable for only once, you don't really declare that anymore. Okay, so over here you can see the I over here. So this actually no redecoration is necessary. Okay, if you try to do something like this, let's say in line number 3, simply say int I is assigned to J. This will be considered as a compiler error. Okay, you don't really redeclare any variable. Okay, and now how do you trace this particular line over here where you say I is assigned to J? Basically, what you're trying to say is copy whatever that's on the right-hand side, the value of that, into the left-hand side. That's how you interpret that. Whatever the source is, saves that to the target. Okay? So now, what's really the source over here? You're referring to 32 over here, and save that to the target over here, which is I. That means you're going to replace this 24 here and save that as 32. Okay? That's what you have. And finally, if you see line number 4 over here, you can see we have another declaration over here for the variable, which is called K. Okay? And then how do you really do that? So basically just having a new box over here called K, and then you're copying the value for I, which is the right-hand side. And what is that in that case? 32. So basically copying 32 into this particular variable K. So you got 32 here. So this is what happened after these lines of execution. Okay? Everybody comfortable with this kind of code? Okay, very basic. Okay? Okay, so now that's about the assignments and everything I've covered already on the slides. Okay, you can just go over them. So now one more thing to say, you can see over here, when the last line over here, when I say string name1 is assigned to this particular expression over here, okay? We're going to go over this, let's just go over that very quickly, okay? Just this particular one. Let me copy that first to my iPad, and then I'll show it to you on the, give me just one moment. I'll copy that first. String name 1 is assigned to 1 plus 2, and then multiply 23 modulo 5. Okay, so this is line we have, the last line. Let's try to analyze this particularly, okay? Let me give you the conclusion first. This line is not going to compile in your Eclipse, but let's see why exactly. Again, let's review the terminology, okay? So this part over here is the source. And this part over here is the targets. Okay, and then let's see from each one of them. If you look at this part over here, just in isolation, is it going to return some result back to you? This one, yes, right? Because you can see 1 plus 2 will actually give you 3 over here, right? And 23 modulo 5 is going to give you the remainder, right? Which will be 3 as well, right? And then 3 multiply 3 will give you 9. So this is the result from the right-hand side. However, the meaning for equal sign over here is to store whatever the source value is into the targets. But now, can we actually do that assignments over there? Well, we shouldn't be able to, right? Because the key thing is we declare this particular variable to be of type string. That means you can only store string only. Store string values only. And now over here, if you try to store 9 over here, that is not good. Okay? That is why if you want to write something like this, it is not going to compile. Okay, so this is not valid. Okay, just a simple example. We'll see more complicated example a little bit later. Okay, hopefully you're okay with that. Now, let's talk very briefly about name constant variable. It's a very easy concept. Okay, so there are two kinds of things you can declare in Java. One is called variable, which we just see, and another thing is called constant, which means you can only give that a fixed value and never change it. For example, the pi for the circle, it never changes value, right? It's always 3.14. There's no point to change it. Okay? Let me show you one example here, and I'll show you on Eclipse. So we got either name constant or a variable, right? We have seen variable already, but we're going to see constant as well. The only way for you to distinguish between the two is to look for a keyword called final. Okay? So now let's have a look at that. Have a look at these two lines over here. Okay? So we have basically final double pi, and also we got double radius. Okay? You can see the way we declare these two things over here. The first one, we actually got a final. The second one, we don't have a final. Final simply means whatever value you assign to it will be the final version. It doesn't change. If you try to change it, it's going to be considered as a compile time error. Okay? So now let me just see if I got example of it. Yes, what I do. Let's have a look at this. I also made the source code available to you. You can also try on Eclipse. I'm just showing you on this snapshot. Let's say we have a class over here. It's called constant cannot be reassigned. Okay? And apparently you can see we do have some compilation error with a red cross. We know that it's exactly this line over here, and then it's something to do with here, with the pi. But let's see what's going on over here. Okay? So now, have a look at this line here. I'm going to highlight it. If you look at this line here, notice that we are using the keyword called final over here. As soon as we say final, that means this particular variable pi can be initialized but cannot be reassigned. That's really the meaning for final, which means you can only do it once, only once. So that means you can think about, we also got a box which is called pi, and then once we put 3.14 for the very first time, we cannot change the value anymore. right? You can see over here, when you intend to do the following, if you say pi is reassigned to 6.28, conceptually, you're really trying to replace this value here by 6.28. However, this is not allowed. Okay? It would be a compilation error. If you look at what's really produced in Eclipse, it's going to tell you because you declared this to be a constant, so you cannot do that. Okay? Now, let's just illustrate very quickly. What about the normal variable? Let's do a contrast. Now, if you look at another class over here where we have no compilation error, that means everything's good. We can just execute the code. Okay? So now you can see it's called variable can be assigned positive, right? So now over here you can see that we declare the variable. You can see there's no final over here, right? And then we say radius is initially 5.4. That means we have a box over here and called radius. Okay, we have a box over here called radius, and then the initial value over here is 5.4. Okay, 5.4. Because we didn't have final, so that means we can reassign this variable for as many times as you like. Let's see exactly what's going to happen over here. So now you can see that for this line here, when we try to print it out, system.out.print line. So what's the radius value at this point? We can see that it's exactly 5.4, so this is going to print out 5.4, okay? And then we go to this line over here where we try to reassign the variable. So now you can see that over here. Okay, the blue one over here. So this one here is called reassignments. Okay, reassign the variable to a new value. To a new value. Okay, so that means we're going to reassign that to 3.9 in this case. So rather than storing 5.4, it is going to store 3.9. Okay. Okay, rather than storing 5.4, it's going to store 3.9. So that means when you try to execute this line over here again, this line here, so what's going to be the radius value? Used to be 5.4, but now because it's being reassigned to a new value, 3.9, so now that means this radius is going to be 3.9. Okay, so now what about this line here? What about the blue line over here? Do you think it's going to be 3.9 again? Yes, because between these two print statements over here, there's no reassignment, so the variable value remains the same. So that means radius over here is still 3.9, the same. Okay, one more time. So if you try to do this line over here, we are trying to reassign the radius to be 9.6. That means replace it by 9.6. Now, finally, if you try to print this line here, and the radius will just be 9.6. Okay, so the way you trace a program, maybe the best way to do it is to draw a box and then try to see if the value get reassigned. Okay, okay, really try to contrast these two examples. The keyword is the final over here, which means you cannot reassign it. You can only initialize it. Okay, that's about the difference between these two. Any questions about name constant and variables? Yes. Basically, this example here is not really trying to compute anything useful. I'm just trying to illustrate to you how you can reassign the variable to a different value. That's what I'm trying to illustrate. So don't worry too much about computation here, right? Okay? Just updating the value, yes. That's the main point. On the other hand, if you look at the previous example here, even for the very first reassignment over here, it's not allowed, right? Because it's constant, right? The main thing is about final here. Okay, so that's about constants versus variables over here. So now let's talk about expressions over here. Okay, let's talk about expressions. How do we really write out expressions? The idea about expression is it can be composed of operations. Let's just see example here. Okay, so and also we got type correct and also not type correct. Let's see examples directly. So over here I got many examples for you about expression. Let's just go over them one by one. And for each one of them, basically you have to judge the following. If it is type correct, which means it has no type error, it compiles, what's going to be the value for the expression? If it does not compile, why not? Right? That's kind of the two options here we have. So now for number 1 over here, does it compile? Really? Okay, why don't we try? Well, for the number 1 here, first of all, can we do this? 23 modulo 5, we can do that. It's going to give us the value 3. And we can definitely do 1 plus 2. That will also be 3. So both sides are numbers. And we try to multiply them together, so it's going to be 9. So it is okay. Okay, so now I would say, I will put a green mark over here. It is type correct. And what's going to be the value? 9. Okay, so now something similar over here. Let's do another one. So what about the second one? It's going to be fine as well, right? So now the only tricky thing is, whenever you see plus in Java, it might mean something, maybe it might mean two possible things. It can either be a concatenation between two string values, or it can be addition between two numbers. Okay? In this case, it's a concatenation. Because you have a one string on the left-hand side, you got another string on the right-hand side. If you try to do them together, concatenate them together, right? So now what you will have is, it will compile, not a problem. And what you will have is, you have a new string. Hello, with a space, and then we have world. Okay, so that's the second one. What about the third one? The third one over here is easy to judge, hopefully. You can see we are trying to do multiply. Multiply should only be applied to numbers. And this is not a number, it's a string. This is not a number either, so this will just not compile. Okay, that's easy to judge, just not compile. So now what about this one over here? Should it compile? Okay, hopefully for those of you who follow the tutorial video, this will compile. But I would say it's a very kind of tricky case over here. There is certain implicit conversion that's done by Java for you. Let's see exactly. First of all, this will compile. Okay? Now, let's think it this way. We have a string over here. So that means this plus, as soon as you have at least one string, that means all the plus sign over here is going to mean concatenation. Concatenation and also concatenation. Okay? You only have the plus meaning addition if you got all the operands being numbers. If you got at least one string values there, they mean concatenation. Now, how do you concatenate them together? Basically, what Java would do, they will basically convert this particular number over here into the string literal 3. They will also convert this string literal over here into 2. And they concatenate them together. So what you will get is hello over here with the space. And then you got 3 and then 2. Okay, this is a tricky case. Okay, basically you don't even add up 3 and 2 together. You don't really do that. Okay. Okay. Another case. Let's say over here. What about this one here? Is it going to compile? It's wrong, right? Because you got multiplication over here, which only apply to numbers. This is a string. This is a number. So this is not good. Okay, so it will not compile. Okay, what about this one over here? No, right? Modulo should only be applied to numbers. However, you got a string value over here, you got a string value over here, which is not right. Okay? Let's do another example. It just came to my mind. Let's do another one. I will do something very similar to this particular example, very similar. Let's see what the value is. Okay? What if I say hello over here, plus, and then I would say 3 plus 2. Okay, so now, is this going to compile or not? Right? I can tell you that it is going to compile. But what exactly will be the output, we got to analyze that a little bit. Really the tricky thing is about the parentheses over here. Every time you got a pair of parentheses in your Java code, that means you want to force that part to be evaluated first. Okay? It's pretty much like how you force the evaluation for addition first before multiplication, right? So now let me just put some notes for you. So this part over here, it tells you you will force the evaluation first. So that means this particular plus really means 3 plus 2. That is addition. Okay, which will give to you 5. And then you got 5 plus hello. In that case, this plus over here becomes concatenation. Okay, so what would you get in this case? What you will get is, if you try to evaluate the whole thing, it's just going to give to you hello over here with a space and then 5. Okay, so really try to contrast this output over here versus this output over here, right? Okay, hopefully it makes sense to you. Okay. Okay, so that's about the expressions. Okay, of course, what kind of expression you want to write for your program is completely up to what you need, right? It's you just need some practice. Okay, that's exactly what I just said over here. Okay, we can just go over them. Now, let's go over this example over here, right? So basically, let's just try to trace the code a little bit, right? That's the intention here. You want to see just so many examples so that you can build an intuition. Oh, actually, we got another one for you. What about this expression here? We got expression 1, expression 2. Okay, expression 1 over here. Is this going to compile? I heard yes, I heard no. Well, notice that we got plus, we got multiply, right? As soon as you got something that's not really addition, there's no flexibility over here. That means the left-hand side for the multiply must be a number. Well, in this case, this is actually a string. So this is not good, right? So string value over here is not good for the multiplication. So you will know that this is not going to compile immediately. Okay? What about the second one? The second one over here, the only thing I changed was from multiply over here to plus over here. That means we got plus over here. And now what should be the output then? Well, the pair of parentheses is going to force us to do 446 modulo 4 first, which will be 2, right? So this part will give us 2. So that means 2 is going to be converted implicitly into the string literal 2. And then get concatenated with these two strings, right? So what we will get is something like this. We got La La Land and 2, like that. Okay, so this will compile, but this one will not. Okay, again, you want to pay attention to how you use the plus. Sometimes they might mean concatenation, but sometimes they might mean addition. Okay, that's the only tricky case you have to pay attention to. Okay, for other numerical operators, it's strict. They got to be applied to numbers. So now let's do this example over here together. Okay, so now. Okay, let's do this example together. We got 2 fragments of code for you. Let's now see the first one. Okay, remember final means it's going to be a constant, right? So that means we're going to have a constant called pi, and then we simply initialize that to be 3.14, and no reassignment is allowed, right? It's going to be fixed this value. And then for this print statement over here, we're going to say pi is pi, which is 3.14, and then pi is pi, which would be 3.14 again, right? You simply doesn't change the value. That one's easy. So now, let's have a look at the second example, which you should be able to answer, but let's just do it together. Over here, we basically got 2 variables over here. We got message, we got counter, right? So we got message over here. We also got counter. Okay? And then the message, the initial value is, counter value is. Okay, I'll say C value is. Okay, just some string literal over there. We stored it there. Notice that message itself is not final. That means we may reassign if we wish. If you do not reassign it, it's going to stay the same value throughout. Okay? And then for counter over here, it's going to store 1 to begin with. Okay, notice that. Now, let's try to figure out the output over here. The first one, what's going to be message plus counter? Well, it should be the counter value is 1, right? Good. And then what about the second one? When we say message plus counter over here again, because in between these two lines, we know that there's no reassignments. No reassignment to message and counter. We know that there's no reassignment, so the output is going to be the same. So we'll say the counter value is still just 1. Okay? Now, what about the third one? The third print statement is over here. We say message plus counter, right? The same expression that we're trying to print out. But now, are we going to change the console output this time? We will, right? The key really is this line I'm going to highlight. Counter is assigned to 2, which means we are trying to reassign the value for counter over here from 1 into 2. So now, when we try to print this out, message will still be the same. Counter value is, what's counter over here? Well, it will be 2 rather than 1. Okay, so when you try to print out the program, that's how the 3 lines you will get. So I want you to get very comfortable with tracing such program for quiz number 1. Okay, next week. All right. Let's now go to, okay, this example we just covered. Okay, let me just illustrate this quickly. So we have seen this for the last week's lab about using the input. Okay, let me just compare with you. The problem is very easy. So all of you have done this already for lab 0 part 1. Let's say we prompt the user for the radius and we want to print out, let's say, the area for the circle. Let's say that's what we want to do. Okay? I just want to show you the difference between having user input versus not having user input. What's going to be the difference? Okay? Okay, what's going to be the difference? So let me show you the code very quickly over here. We got 2 versions here. Okay? So the green version over here is the one without the user input. Okay? I will highlight the line to you. So we got radius, we got area. Okay, we got 2 variables over here. And then notice that this is really the critical bits over here. Because we have no user input, that means we must give us literal values to this particular variable. For example, in this case, 20, right? And then we can calculate the area accordingly using this expression. Okay? So that's very not flexible for this particular program, because every time, if you want to change the value for the area, you have to explicitly modify your program, for example, from 20 to 40, so you can calculate differently. You got to run as Java application again. Okay? That's what you got to do. But what about the second version over here? The second version is really giving you the flexibility of having the user to choose the value they want to get, right? So now, the only new bit is we're going to say we declare some scanner, as we have seen many times. And then over here, input.next double. So this is really where the flexibility comes in. Every time you prompt the user for any value over here, depending on what they really enter, is going to be stored in the radius accordingly. For example, if the first time the user entered 20, that means 20 is going to be stored inside radius. And then when we try to apply this formula over here, radius will just be 20 and 20 over here, right? What if I want another run with a different input from the user? Well, in that case, I'll simply run as Java application again. Maybe I will enter 100 in this time. In that case, this particular value is going to be stored in the radius, which is 100, and then we apply this particular formula using 100 instead, right? So try to compare the two versions over here. That's why we're using the scanner for your exercises. Okay? Okay, let's now go on. So that's the two examples we just illustrated. Okay? Of course, you should know both, right? Okay, so these are the three methods you can use for the scanner. Let's talk very quickly about the common mistakes you can make on your Java program. Okay? The first one, the first one over here, what we have is, let's look at that. Okay, it's a very typical mistake you're making maybe for week number 1. So what's really wrong over here? You can see that over here, we basically have variable name called counter. And we got the same variable name over here. However, for both variables, we are trying to put a data type before that. So that's where the mistake comes from. So here's a rule. You can only declare a variable only once, exactly once. Cannot be more than once. So here, this is redeclaration is simply not allowed. Okay, so that's simply not allowed. If you try to put this fragment of code in Java, it's just not going to compile. So how do we fix it? So there are two possible ways to fix this program over here, depending on exactly what you need. Both are valid, but you got to choose which one you need. Number one, you simply get rid of the declaration, the second declaration over there, which means I got something like this. I say integer, let me use a different color here. So fix number one. You can say integer, and then counter is assigned to 1. So this is the very first declaration I have. I got counter over here, and then initial value is simply just 1. Okay. Now for the second line, I cannot redeclare counter anymore. I can simply say maybe counter is simply reassigned to 2, which means modify that from 1 to 2. That's fix number 1. Okay. What about fix number 2? Fix number 2, maybe what you really meant to say, you want to have 2 different counters with different values, maybe. In that case, we can do it like this. You can say integer counter number 1 is assigned to 1, which means we got one box, which is called counter 1. And then we put 1 over here. Okay, and then for the second one, let's say you really want to declare something. You can just say integer again, but now choose a name that has not been declared already. So you would say counter 2 is assigned to 2. So what you have is you just have a separate box called counter 2. And then you simply put 2 inside. Okay, so now, which fix to use is completely up to you. Okay, but both work. Okay, we still got 5 minutes. Okay, bear with me. Okay, that's the first mistake. What about second one? The second one is also very typical. Basically, whenever you want to use a variable, make sure it is already declared. Okay, let's have a look at this. Try to skim through these 4 lines over here and try to see where it's wrong. Okay, we got line number 1, line number 2, 3, and 4. Can you kind of see which line is already wrong? 1, okay? Let me just explain to you right away, okay? If you look at line number 1 over here, this is the very first line to begin with. Let's say the first line for your main method. You say counter value is, and now this counter here, it is not in string quote. So we know that it is not a string literal. So this means this must be a variable reference. Variable. However, counter has just not been declared yet. It is only going to be declared afterwards. So this is not acceptable. Okay? Make sure every time you try to use the variable, declare that first. So now, how do we fix this one? Well, make sure you declare that first. So what I can do is I can simply say, let's say I get rid of this second line over here. I'll move it before that. I can say before the first line, I can say integer counter is assigned to 1. So make sure you declare the variable before you use it. Okay? So that's also a very typical mistake. Okay, so we also did this one for your lab 0 part 2, right? About converting seconds into minutes, okay? So now let me just show you what I want you to do as an exercise, okay? Basically, hopefully every one of you were able to use the quotients and also modulo operator over here, right? So now I have an exercise for you. So now let's try to expand the example a little bit, okay? I want you to modify the program so that it's also going to display hours. One example for you. Let's say I give this to you, 7,945 seconds. I want you to modify your program so that it's going to output 2 hours, 12 minutes, and 9 seconds. Okay? It's only going to be 1 or 2 lines you have to modify. Okay? That would be an exercise for you. You just have to exercise more about the modulo operation. Okay? Okay, that's an exercise for you. Okay? Okay, now let's summarize basically a little bit. We talk about how we can do variable assignments. So now it's really about the right-hand side of the assignments. You have to be creative. So let me just give you some rule over here. So this is a typical form for the assignments. You got equal sign for the assignments. Right-hand side is the source, and the left-hand side is the targets, right? We just want to see, okay, give me 2 minutes, all right? Guys, please, give me 2 minutes, okay? So now, what can we put on the right-hand side? You can put maybe literal, just write out the values directly. That's what we have seen a lot. Or it can be just another variable, which we also have seen, okay? That's the second case. Or it can be some kind of expression. For example, you can see variable over here, and also you got multiplied by 2, right? Just some expression. And now what we have really learned last week was you can also say input.nextInt. So this is going to give you whatever the user entered from the keyboard. So this is also another possibility you can put as the assignment source. Okay? Now, okay? Any questions? Okay, I'll see you on Wednesday.